So here, the 2019 Higher Paper 2, question 1. This question here relates to straight lines and the properties of straight lines in relation to one another. Now it's got 3 parts to it. First is looking at the median, second is looking at the altitude, and the third is looking at points of intersection between 2 lines. So let's break this down, look at each part individually and some of the key terminology as well as how to calculate them. So the first one here, find the equation of the median BD. So this one here is using the term median. Now median is a line which goes from here to the middle of a line opposite. So it goes from the point B to the middle of the line CA. So that's what we know about that. So if we were to look at it, this and this, they would be even. They would be the same size as one another. So we know it goes to the middle of that. Now, in order to get a straight line, remember we need 2 key properties. We need the gradient and we need a point. Now sometimes that point is the y-intercept, sometimes that point is just a generic point somewhere upon the line. What we need is those bits of information though in order to be able to get the equation of our line that we're after. Now for the equation of the median BD, first thing I want to do is get the gradient of the line B to D. Now I have the point B, great, but I don't have the point D. Remember, to get the gradient, so we'll put part A here, to get the gradient, I know I need y2 minus y1 over x2 minus x1, where x2, y2 and x1, y1 are 2 points on the line. So I've got one of the points, which is great. What I need is the other point. Now the good thing is because this is the median, we know it's in the middle of the line, I have the point A and the point C, so what I have to do is find the middle of those 2 points, and I've got my coordinate for D. So what I'm going to do is find the middle of the x's. So I've got -5 and -3, so the middle of that is at -4. I've got my 2 y's, so I've got -12 and I've got 6. So what I'm going to do is find the middle of those 2, which is at -3. So I know then that the point D is going to be -4, -3. So I've now got my 2 points. I can use them to calculate the gradient. So if I substitute them into the formula, remember it doesn't matter which way around we allocate the points to being x2, y2 and x1, y1. Key thing though is we have to remember that the x1 and y1 stay together, the x2, y2 stay together, so we don't mix them up. So we don't have, for example, x2, y1 and x1, y2. We have to make sure they're the right way around. So if I stick the information in here, what I'm going to end up with is -8 take away -3 over 11 take away -4. And if I look at that, so -8 minus -3, minus becomes a plus, so -8 plus 3 gives me -5. 11 minus -4, so 11 plus 4 is 15. So my gradient is -1/3. So now I've got that bit of information. I've got any 2 points on the line will work for what I'm going to use to substitute in. So any of these 2, and then we just go ahead and substitute them in. So let's substitute them into the formula for y minus b equals m bracket x minus a. Now remember, for this formula, your m is the gradient and your a and b come from a point on the line. We've got 2 to choose from. Shouldn't matter which one we choose, we'll get the same answer either way. So if we choose the point D, what I'll end up getting is y, so it's minus b, so the b comes from the y part of the coordinate. So it's y minus -3, so that gives me y plus 3 equals the gradient, so -1/3 bracket x minus a, so it's -4, so x plus 4. So what I'm going to do is rearrange this. I want to get rid of these fractions. I'm going to put in the equation, the general equation of a straight line format. So if I multiply through it by 3, what I'll get is 3y plus 9 equals -x minus 4. Stick it all on the left hand side, and I get x plus 3y, take the 4 across there, and I get plus 13 equals 0. So there we go. That's the equation of a straight line in this case here. We could have it in any of the other formats we want. So we could have, 3y equals -x minus 13. We could have y equals -1/3 x minus 13 over 3. There's various ways we could have it. This here just seems to be the best way for me anyway, because I don't like having fractions in it. Second part, part B, equation of the altitude of AE. Now remember, altitude refers to a line in a triangle that goes from a corner, so let's say this vertex here at A, to the side opposite it, so where it would meet at this point E, but it creates a 90-degree angle between that line and the base of the triangle. So the two lines here, the CB and the AE, would be perpendicular to one another. Now again, in order to get the equation of a line, we need those two bits of information. We need the gradient, we need a point on the line. Now for this one here, I've got the point A. That's given to us up here. However, I don't have the point E, and because it's not a median, like this one here, D, where it met in the middle of this line, E can't be assumed to be the same. We don't know it's in the middle, so we can't just take that as being a property and find the middle of the points B and C. So we've got the point, but we've not got the gradient, and there's no way to calculate it with 2 points. However, what we have to remember is the property that when we've got two lines that are perpendicular to each other, such as this, we know that M1 times M2, the two gradients of the line, the product of them, is -1. So we can use that fact. So if we calculate the gradient of B to C, we can then use this to get the gradient of A to E, and I've got all the information I need at that point. So if I do the gradient of BC, what that then means is I do -8 take away 6 over 11 take away -3. So -8 take away 6 is -14. That's then over 11 minus -3. So that's over 14. So it's -1. So that's the gradient of BC. So I then know that the gradient of AE times that gradient, so times that -1, gives me -1. So from that I can say fine, so the gradient of AE is equal to 1. So now that I've got that, I've got this here and I've got a point A on the line, I can just stick all the information together to get my equation. I then know that y minus b, so remember b and a in this case will come from that point A, so y minus b is y minus -12, so it's y plus 12, equals mx, so it's 1 bracket x minus a is -5, so it's -5, so it's +5. From that, I can then simply say that y equals x minus 7. So that there's the equation of our second line. That's the equation of the altitude A to E. Last thing I want is the coordinates of the point of intersection of these two lines. Now remember, point of intersection is that unique point where the two lines are equivalent to one another. So there's a couple of ways we can do this. We could rearrange this to be something equal to 0, set the two lines equal to each other, and then use simultaneous equations to solve. Or, because I've got this here in this format, I've got y equals something, what I could do, and it's the method I'm going to use here, is substitute it into this equation here, take that equation which has two variables and stick it in terms of one variable x, solve for that x, and then substitute the x back into here to get the y part of the coordinate of intersection. Bob's your uncle, I've then got the point that I need. So to start solving this, I'm going to substitute y equals x minus 7 into this here, and what I'll get is x plus 3 bracket x minus 7 plus 13 equals 0. So multiply it out and start to simplify everything out. So I've got 3x and an x there, so I've then got 4x. Then got 3 times -7, so it's minus 21. Minus 21 plus 13 gives me minus 8, that equals 0. So I then know that 4x is 8, x is equal to 2. So I know my x value here. If I substitute it into here, I'll get the y value. So I know that y is equal to 2 minus 7, so it's equal to -5. So I've got the y and the x part of the coordinate. Then what we have to do is make sure we explicitly state it. So we then say that our point of intersection is equal to 2, -5. Remember to state that explicitly. X is 2, y is -5. These are values for x and y. We have to put it in the right format because it wants a coordinate of a point of intersection. This is how we write a coordinate down here. So this is how we represent our answer at the end. So quite a few different things we have to remember from straight lines there. You know, altitudes, medians, points of intersections, equations of straight lines and how to calculate them. But nothing too hugely difficult. It's just recalling that knowledge from right back at the start of the course and back in National 5 material as well, and being able to bring it forward and apply it here in this scenario.